Okay, so hello everyone, good evening, or for those of you that are in different time zones, good afternoon, good morning, wherever you are. So over the next 20-25 minutes or so, I'm going to talk about a few examples taken from my research. First, it's taken from my research that I have been doing over the last few years, and they all will have kind of hopefully kind of a linked story that links the various projects together. So as I said, I'm a lecturer in data science at the University of Exeter, and previously to that I was working at Warwick Business School as in the data science lab. So the work that I present here has partially been done at data science lab in Warwick Business School and partially been done at Exeter over the last year or so since I've been here. And what I'm going to talk about is how we can use new forms of data that are now widely available. So we now all use smartphones. We are all now living on Zoom effectively. We all use social media. We can use things like Twitter or Instagram or Facebook. And we use all sorts of digital technologies to basically support our daily lives. And all of this technology generates a lot of data, which contains a huge amount of information about our behavior. And my research focuses on exactly kind of analyzing these new forms of data alongside more traditional forms of data to understand human behavior in a variety of contexts. And the context I'm going to talk about tonight in particular is understanding different groups of people. So the first, let's see if I didn't change the slide. Okay, the first set of examples I'm going to talk about is how we can use these forms of data to measure the size of a crowd. So by crowd, I mean a large collection of people. Imagine thousands or tens of thousands of people. So why would we want to do that? Well, large crowds gather in a kind of a variety of different circumstances. So they could gather in large events. There could be a parade or a large concert, for instance, where large crowds gather. There could be some form of protests where large groups of people gather to protest against a political party or a specific government and so on. Or there could be large crowds which are gathering in kind of political events like the inaugural ceremony of Trump's presidency. Now, in this case, I like to use this example because if you remember when this happened, there was a big kind of controversy, if you want, on the news about how many people were there, and in particular compared to how many people were in exactly the same area, but I think a couple of days after when there was the Women's March. There was, some people were saying that Trump's inaugural ceremony had more supporters, some other people said the opposite, and this was really kind of, quite debated in the news. So knowing the size of the crowd is interesting for news recording, but you might think that actually the way the news are recorded and released might affect the public's perception, in this case of a president, a political president, or a specific movement, but more generally, the perception the public has about a specific event, a specific movement, a specific person might be affected by how the news say, this person has hardly anyone attending their event or so on. However, this is not the only situation. In emergency situations, where, for instance, in this case, you have thousands of people gathered in an area, the authorities, so police forces or event organizers, might want to know how many people are there in order for us to be able to evacuate them as quickly as possible, for instance. So there's a whole set of reasons why people are interested in measuring the size of the crowd. However, traditionally, this is a very difficult thing to do. And why is that? Well, traditionally there are a couple of ways in which you could try and do this. One would be to take pictures like this one, and then maybe zoom in into a small area, see how many people you can count in that small area, and then kind of scale it up to the whole area. This is an approach that has been used quite extensively in the past because it's relatively simple, but it takes time because someone has to physically sit there and look at the image. It requires high resolution images of the whole area, and so it's time consuming, and also because a person has to do it, it is prone to errors. So if I did it and all of you did it, we probably would come up with different estimates. You can then kind of combine them statistically, but still this wouldn't necessarily be the fastest and best way of doing it. Now you might think that with technology you might be able to use things like cameras and face recognitions technologies, which can work, But the problem with that is that they only work if they are able, the camera, for instance, is able to see the crowd. So if there are obstructions, like obstacles like trees or parts of a building or cars, vehicles, lorries, and so on, which obstruct part of the crowd from the camera won't be able to measure how many people have gone, have entered the area. So camera technology, for instance, can work well in situations like measuring the influx of people across a road, because that's a reasonably small environment, and typically you can set it up so that it doesn't have any visual obstacles. But in a large environment like this one, it might not work as well. So what can we do? Well, the idea that we had was, in this crowd, like in most crowds, I mean, now they don't gather anymore because of COVID, but pre-COVID, in most crowds, people would simply have a smartphone with them. You might have a phone with you to meet up with someone else who's in the same, attending the same event. You might make a phone call to them. You might take a picture and then share it on your favorite social media platform, be it Instagram or Twitter. So all of this volume of information that we're generating is there. Can we use it to actually measure how many people are there? Now, to do this, there's a few things that we need to test this hypothesis. First, we need the data, and second, we need a case study. So the data, I was lucky enough to have access to a large data set of mobile phone records for the city of Milan in the north of Italy for a period of a couple of months. And these data contain information on so it was anonymized, so it didn't contain information on like what people were talking about on the phone, but contained information on how many phone calls were made in different parts of the city, how many text messages were sent in different parts of the city, and how much people were using the internet in different parts of the city. And what you can see here, hopefully it comes across well across the screen, is that the darker shade of red indicates more activity coming from mobile phones. And of course, as you expect, you find more activity in the center of the city, which is kind of the center of the map here. But we wanted to go beyond that. So we have the data that we need. But the problem is, okay, we have the data, but because the challenge of measuring the size of the crowd accurately is difficult, how do we pick a case study in which we know exactly how many people there are so that we can calibrate our model effectively? So the example that we came up with was that of football matches. And as an Italian, I know it's a difficult way to talk about football in England, but please bear with me. So football matches happen in a football stadium, which is a kind of spatially confined area. You need a ticket to get in, and you can only get in for a ticket. If you have a ticket. And football matches take place over a reasonably short period of time, a couple of hours or so. And the number of people, the number of tickets sold is publicly available. So the idea we had was, well, can we extract from this mobile phone data, and also we combine it with data derived from Twitter. So can we extract the information coming from inside the football stadium and compare it to how many people were attending different matches in our time period? And that's what you can see here. So at the bottom, we have the number of attendees, people attending different football matches across the 2-month period. And at the top, in the top three plots, we have the activity derived from the different sources of data that we had. So phone calls and SMS sent and received, how much people were using the internet on their phone, and how many tweets people were posting or sending from Twitter, from the football stadium on Twitter. And as you can see, we found a very strong relationship between the two variables. So for instance, just kind of visually, we did some statistical analysis further, but visually you can see that the match with most attendees was also the match, so on the bottom right is the one that has the most tweets, the most internet activity, and the most phone calls and SMSs. So this was quite promising because it showed that actually, in this very simple example of one stadium, 2 months of analysis, which is only, I think it's 10 or 11 football matches in those 2 months, but it still shows very promising results. Encouraged by this, we then decided to go further and try to extend this study to a longer time period, so effectively to have more data. And what we used was data derived from Instagram. So what you will see in a second when I start this animation is the location of all the photos posted on Instagram in one specific day in the city of Rome throughout the day. So hopefully this works. So you see that as the day progresses, we start seeing more and more photos being posted to Instagram in Rome, and in particular in the center of the town. But this is not a random day. This is a day of an important football match. And if we focus on the area of the football stadium, we see that throughout the day, there's not much happening in the stadium because no one's there. But actually, as we approach the match, we see a sharp increase in activity coming from Instagram during the football match. Okay, so these are all the people that are posting on Instagram photos from within the football stadium. And this was a much longer study, so we did this actually over a whole year, and for 2 cities. So we looked at Milan and Rome. So we had, I guess, an improvement compared to the previous study in the sense we had 2 locations instead of 1. We had a 1-year time period, which means that we had about 40 to 45 matches in each stadium instead of just 10. And this also allowed us to test our hypothesis in the 2 different kind of settings, if you want. Now, I always like to say when I talk about this, when I present this figure, so you might see that there are some photos posted on Instagram inside the stadium for which there is no corresponding attendees. So that's the kind of shaded gray area where it says no matches in this period. That's because football stadiums are used for other things like concerts, for which we don't have official attendance figures, so we can't use them in our analysis, but for which we have the Instagram data. So we don't include that in our analysis, but I include it in this plot so that it's clear that we have the full year data. And actually, as a fun kind of anecdote, the highest number of users posting on Instagram in Rome is actually during a One Direction concert, which is what you can see in the peak on the right in plot D. So this is what we did here, and again, it kind of gave us further evidence that we can actually use this data to measure how many people are in a location at a given time, or during a short period of time of football matches, a couple of hours. Now the next thing, my slides have frozen. Okay, the next thing, just to kind of close this first set of examples, is that when working with this kind of data, it's important to bear in mind that, I guess, there are new forms of data that are constantly changing. So, for instance, if you keep the example of Instagram, the number of people using Instagram changes over time. At the time when we did the study, the Instagram was becoming kind of increasingly popular. So this was around 2013, 2014. And this is actually an effect that we can see in the data. So without going into too much of the technical details, if you focus, for instance, on the top left plot, the one in Milan with the 2 lines. Now, the 2 lines are simply the best fit to the football matches between, so the number of people posting on Instagram during a football match and the number of people attending the football match, but split by season. So we have, because we have a year of data, we have roughly 6 months, so 1 season and 6 months of the other season. Now, what happens is that kind of consistently, both in Milan and Rome, the blue line, which is the one of the second part of the year, so the second of the season, is lower than the first, the red line, which is the first part of the season. And this is because the number of Instagram users over time was growing, and therefore this effect became noticeable in the data. And the reason why I want to highlight this is that when doing this analysis is important, as much as it's kind of exciting to work with this data, it's important to bear in mind what the data that you're working with is like. And in fact, what we've done is in the middle plots, so C and D, is that if you actually take into account the fact that the number of people using Instagram is growing, and you normalize for that, you account for that, actually you can collapse the 2 lines effectively on the same line. So if you see in Milan and Rome in the middle row, the 2 lines are, they're not exactly overlapping because the data is noisy, but they are of a much more similar slope, which is kind of addresses the point that was made. So this is the first example that I'm going to talk about. Well, I guess 2 examples. Now, what I'm next moving on to is again measuring the size of a group of people, but instead of a short period of time, like a football match, which is say 2 to 3 hours, of a much longer period of time. So in particular, the period of time of around a month. So what we're going to talk about is how we can use similar forms of data to measure groups of people over a monthly period. So this was a project that was done, that I did a couple of years ago in collaboration with the Department of Digital, Culture, Media and Sport. And we were looking at attendance to museums in London. So in London, every month, again, pre-COVID, tens of thousands, in fact, hundreds of thousands of people visit the museums. So they could visit the National Gallery, the kind of more classical art that there is there. People visit the Tate Modern with the kind of more modern and contemporary and often controversial art they have there, or they might visit the Natural History Museum. So hundreds of thousands of people visit these museums on a monthly basis. Visited these museums, I guess, on a monthly basis. These museums are sponsored by the Department for Digital, Culture, Media and Sport, in short, DCMS, which is great because it means that they are free to access. Of course, we don't have to pay a ticket to go in, but it also means that DCMS is interested in knowing how well these museums are performing. But because they don't require a ticket to be accessed, it's a bit complicated for them to understand how many people visit them on a monthly basis. Each museum collects this data separately and then sends them to DCMS kind of on a monthly basis. But this is a slow process, which takes some time. This data is then kind of aggregated and kind of quality controlled, and then is released by DCMS to the public on their website. So at the time when this study was carried out, this data was released on a monthly basis. It's changed since, and now I think it's quarterly, but for the sake of this example, let's stay with monthly. So this data is released to the public with a delay of 1 month via the website. Okay, so what this means is that, for instance, if you wanted to know attendance figures for different museums in London and across the UK for August 2018, you actually had to wait all the way until the beginning of October. So that's a delay of just over a month. Now, in many situations, you might think, well, this is not a problem. But in some situations, having a quick access to how well or how badly different museums are performing might be useful to design better policies to support culture and museums, for instance. So what we worked with on this in this project was, can we provide complementary ways of understanding how many people are visiting different museums across the UK on a monthly basis. Now, let's take Tate Modern as an example. So, as I said, the data is publicly available. So on a monthly basis, Tate Modern had, again, pre-COVID, between 400 and 600,000 visitors. And so as you can see that, the data kind of varies throughout the year. In particular, typically in summer, there is more visitors than compared to other parts of the year. So how can we try and estimate how many people visit a museum on any given month? Well, the simplest approach you can take is, well, let's say that each month the number of visitors to Tate Modern, for instance, so say in August 2014, well, because this data is highly seasonal, every summer there's more people than in spring or winter, for instance, I'm going to say, well, the number of people visiting Tate Modern in a given month is going to be similar to the number of people visiting that museum on the same month of the previous year, because roughly speaking, summers are always higher than winters, for instance, and so on and so forth. So this is a reasonable approach. In some situations, it's very simple, of course, and sometimes it can work well, but in some situations it doesn't work very well. So for instance, in August 2015, there was quite a sharp drop in the number of visitors. I think it's due to part of Tate Modern being closed, I think, for refurbishment. And so this approach, as much as it's simple and intuitive to understand, doesn't work very well. And if you do this kind of on a consistent methodological way, you actually get an error if you predict the number of people visiting the museum on a monthly basis, which is of around 40%. It's not great. Of course, this is a very simple method. Now, there's much more sophisticated kind of method to analyze data. So this data is time series data, so data that varies over time. And if you use a slightly more sophisticated method, like NARIMA model, which is a specific way of analyzing time series data, you can actually reduce your error to around 23%, which is much better already. But what we really wanted to do was, can we do even better? And in particular, can we do better by including information on what people are looking for online? So if you are, I don't know, like me and many other people, if you want to go, say, to Tate Modern, you might want to know, where it is, how you can get there, when it's open, is there any special exhibition on? And if you do this, chances are that you're going to look it up on Google. Now, Google releases search volume for specific topics publicly via the interface called Google Trends. So what we used was, what we thought was, can we use the volume of information that people are searching for on Google for different museums across the UK to complement and enhance our model to produce better estimates? And the answer is yes, otherwise I wouldn't have mentioned it probably. And in fact, we can reduce, for instance, in the case of Tate model, to around an error of 14.5%. But the key message, I guess the key messages here are two. One is that we can do this by, including Google Trends data, so information on what people are searching for online, to improve our model, improve our estimates. But the second key message is that, data on what people are searching for online is available on Google Trends in a way kind of real time. So as soon as the month is finished, so if you go back to the beginning when I was saying, if you wanted to know how many people visited museums in August 2018, as soon as August 2018 is finished, Google releases how many people, or something proportional, I should say, to how many people searched for Tate Modern in August 2018. So I can use that on the 1st of September, effectively. So I don't have to wait a whole month to generate my estimates. So we have accurate estimates which can be generated quickly, which is what we set out to do. And then, so, just kind of to emphasize the point already made, we run this, I talked about Tate Modern so far, but we actually run these across different, effectively all the museums sponsored by DCMS. We tested for different models, so we used an ARIMA model, which is one method of analyzing time series data. We use neural networks as well, which is a different method for analyzing the same data. And these results hold consistently, across the museums and across the different models that we tested for just kind of to make sure, to show they can be generalized in a way. And then finally, one counter argument could be, well, maybe, you can, data for what people are searching for on Google doesn't necessarily have to be directly related to the museum. So maybe if you use how many people search for on Google to, Buckingham Palace or other tourist attractions, you could also use that. So then you would kind of, reduce the strength of our, or robustness of our results. But we actually tested for that, and our estimates can only, are only accurate if you use information specifically about the specific museum or gallery that you're trying to analyze. So we controlled, so we tested this using different terms. And if it, for instance, as I said, if you use how many people search for on Google for Buckingham Palace, which you can think is going to be somehow proportional to how many people are visiting, are interested in visiting London, Buckingham Palace. But actually this information doesn't contain relevant information for how many people are going to visit a different museum. Okay, so really the information about what we search for online related to a specific topic contains information about how many people are going to visit that specific site in this context. And then finally, just last quick example is measuring. So again, it kind of got to do with groups of people. And in modern world where we live in larger and larger cities, people, like urban planners and authorities are interested in knowing what makes different urban environments vibrant. So what make an environment busy effectively? Why do people want to go there? Are there specific characteristics that different urban environments have that can help it become more vibrant? So this is something that has been studied a lot in the literature already. Some people, the kind of intuitive things that foster vibrancy are things like shops and restaurants and places where you can socialize effectively. But also there's been studies looking at how the actual structure of cities, so for instance, how roads are placed in a city, can enhance effectively the willingness of people to spend more time there. And if there's lots of roads that intersect one another, that effectively allows for people to just kind of walk around. Instead, you have very few intersections, just lots of long straight roads which never cross one another. Then it's kind of harder to bump into people effectively, and this reduces the willingness of people to spend time there. And then finally, also green spaces. So there's lots of research on green spaces and how they affect health, both mental and physical. And of course, green spaces and parks and so on are in some way must be related to us, so people wanted to spend time there. And again, we can now study this because we have access to mobile phone data. So mobile phone data tells us not only where people live, that's, we got a census to know where people live. But mobile phone data tells us where people like to spend time. And in this particular study, we looked at how different people of different age groups, where different people of different age groups decide to spend time in the city of Milan and other Italian cities, actually, over time. And the reason why this is interesting is that there's relatively less literature that looks at how different parts of the city foster vibrancy for different age groups. So maybe things that may encourage young people to spend time in a part of the city maybe are not the same that encourage older people to spend time in a part of the city. So this study, we looked at exactly that. And I'm not going to go into the technical details, but we looked at effectively a range of different features of cities. These are features that are derived from the census. So things like the density of a city. Now, because we live in kind of denser and denser cities, we have to talk about density, not just the number of buildings, but also the kind of vertical density. So if there are lots of tall buildings. There's some evidence that buildings of different ages are as older and more modern buildings combined in the same area might be might foster people to spend more time there. This has to do with kind of the way the business in the economy works as well. But also we looked at crowdsourced data. So crowdsourced data from OpenStreetMap. So OpenStreetMap is, in a sentence, is an openly available crowdsourced version of Google Maps, sorry. So it contains information on what types of buildings, what types of roads there are. It contains information on different points of interest. So that's what labeled the POI. So where restaurants, museums, monuments, interesting things are across the city. And then, building on the urban literature, we used the concept of third places, which is the idea that in life there are three places. The first place is where you live. The second place, which is where you work. And the third place is really kind of the place where you go to spend time to socialize or to do some activities. And so we kind of used that from to understand whether different age groups had different connections to this. And so the results that I'm just showing you here is that there are a strong relationship between what we present, what we find in different parts of the city, and people spending time there. However, this seems to be relatively constant across different age groups. Now, this is simple correlation analysis I'm showing you here. We actually built more complex models, taking into account spatial structures across the city and so on, but I'm not going to go into the details of this. But the take-home message is that, again, we can use mobile phone data to understand where people are. And in this specific case, we can then use this to understand what makes different parts of the city more or less attractive to different people, which is something might be useful for, again, policymakers that might be interested in designing different parts of the city that encourage people to spend time there, encourage people to spend time in safer environments, in environments where they feel happy and at ease socializing. So this concludes my last example. So just kind of to recap, what I've shown is hopefully some interesting examples of how we can use new forms of data combined with traditional forms of data like the census, as I just mentioned, to really better understand our behavior in a kind of a collective scale in this case. So where crowds of people gather for a kind of small period of time, like a football match, or similar types of event, on a broader time scale, on a monthly basis in a museum, and more generally how people and where people gather across different parts of the city and how that relates to the actual underlying structure that we have in the city. So thank you very much. I hope it was interesting. And yeah, if you have any questions, of course, feel free to ask them now, but also feel free to get in touch later on if you wish.